Today we are going to discuss about one-dimensional wave equation. For this one, just assume that we have taken a string and it is fixed from these two endpoints. Okay.
Yes.
And this is, you see, it is called wave equation. This is the standard formula for the wave equation. Dou square u by dou t square is equal to c square into dou square u by dou x square, where c square is a constant, any constant here. So two ends of the string will be fixed. It is not going to be moved. It is fixed. The endpoints are fixed. We are going to have this equation. We are going to find out the solution for this standard wave equation. So I'm going to solve it with the method of separation of variables, and we are going to get some different types of answers for this wave equation. Among this all answers what we are getting, only one answer will satisfy this wave equation. You have to tell me which equation should satisfy this wave equation. Okay, this is the suspense for you. We'll start.
Okay.
Let us assume that this is fixed two endpoints. Coordinate axis we are taking, so x is equal to 0, and here it is x is equal to L. These two are the fixed points. Now our given wave equation is dou square u by dou t square is equal to, let's say, c square into dou square u by dou x square. Let us take this is equation number 1. Okay, yesterday's concept you remember?
Yeah. U
Let
of
let
community.
let the complete solution of equation number 1. Let us assume that the complete solution of equation number 1, u of how many variables are there? X and t are involved in here. Okay, so here x is a function of x, we assume. Similarly, t is also a function of t. Okay,
Yes.
this is taken as equation number 2. You have to find out this capital X and capital T values. Okay, now what is our requirement? We have to differentiate this value of u with respect to t 2 times. This implies when we are going to differentiate partially the value of u with respect to x, we will do this part first, no problem, order is not important, is equal to, with respect to x, when we are doing, you can see t is a constant. Okay, t is a constant, x will be differentiated 2 times. This is x double dash, correct? And dou square u by dou t square. Similar story, but in a different way. How it will be? It will be t double dash into capital X, correct? Because we are differentiating t 2 times, so t double dash, and x will be a constant. Now we have to substitute these values in equation number 1. Substitute these value in equation number 1. So when substituting these values in equation number 1, our equation number 1 will be reduced to dou square u by dou t square. Answer is here we have. Can you tell me what is that? T double dash of x is equals to c square is a c square only. Dou square u by dou x square value is what? T into x double dash, right?
Yes.
Now by separating the variables, by separating the variables, separating by separating the variable. You have done this concept before in your college? Wave equation simplification, solution of wave equation.
Yeah.
Same way, the same method,
Yeah.
T double dash,
Yeah.
and this similar terms will be coming down along with the constant I am taking c square also, which is equal to, here we have x double dash, and this terms x will go down. Okay, we have separated the variables. P will be in one side and then x will be in another side. And as I said yesterday, if you have two variables and they are equal, it is possible if and only if it is equal to some value of k. Then only we can say these two variables are equal to each other, where k is any constant.
Yeah.
So two cases we have to deal. Case number one, t double dash upon c square into t is equal to the value of k. Okay, and then if you cross multiply, this will be going that side. We're getting t double dash minus k c square into t is equal to 0. This is taken as equation number 3 we have to take. And similarly, another case is x double dash by capital X is equal to k. Once again, cross multiply and simplify. X double dash minus k is equal to 0. This is called it as what? It is taken as a fourth equation. Any doubt till here?
No.
No. So entire solution of this wave equation is depending upon this value of k. This value of k, it will be depending. So value of
Yes.
k, it is depending. So there are maybe three cases possible. Maybe k is negative, k is positive, k is equal to 0. You have to deal all the situations. You have to deal all the cases. What happened when k is equal to 0? We can see case 1. Case number 1. All the three different situations we have to deal. Case number 1, when k is equal to 0. So then what happened to the equation number 3 and 4? Okay. If you put k is equal to 0 in equation number 3, what is the answer you are getting? You're getting your answer is t double dash is equal to 0 only. Am I correct?
Yeah.
Which implies if I'm integrating first time, one term of differentiation will be cancelled. P dash is equal to, we are getting some constant. Right? Integrating on both sides. One differentiation and one integral term is cancelled. And when integrating, you have to write a arbitrary constant, that is C1. Now integrate one more time. Understand these steps?
Yes.
One more time we have to integrate. You will get t is equal to, here t is a function of t only. So when integrating C1 with respect to t, you will get your answer C1 of t plus some arbitrary constant, that is C2.
See.
This is the value of t. Perfectly we are getting. Similarly, the same value of k we have to substitute as 0. What I'm getting here, x double dash is equal to 0, which implies that if I'm integrating on both sides, I'm getting my answer x dash is equal to C1. And if I'm integrating one more time, that is x is equal to, what we are getting here? Not C1. Please don't take C1. Already C1 is taken here. So I am taking C3 here. Okay. So one more time integrating, x is equal to what I am getting here? C3 of x is a function of x. So C3 of x plus C4. It is one more solution. We got it. So when k is equal to 0, we got the solution of our equation number 1, x value and t value, we got it. So hence the complete solution we write. Here we write hence the complete solution of, it is a long answer, okay, lengthy problem. Solution of 1 is, hence the complete solution of equation number 1 is, what type of solution we got? U of x comma t is equal to, okay, now we can see What is the value of t we got? This is t. C1 of t plus C2, and this is x. Our solution is x
Yeah.
into t form. So write in that order only. C1 of t plus C2 into here what? C3 of x plus C4. Okay. So
Yeah.
we got one solution when k is equal to 0, and this is called algebraic solution. This is algebraic equation actually. Algebraic equation. I will discuss later on why I am going to call this one as algebraic equation. Next, continuing, assuming that the case 2. What is the case 2 we have to take? K is we take as a positive or negative, any one of the case. That is, I am taking positive here first. When K is positive, when K is positive, let us assume that K is equal to some positive value. I am assuming K is equal to some p square. Okay, because if you take any number and make it a square, definitely the term will become positive only, no?
Yeah.
The term is always positive, where p is any number. Where p is any number. Where p is any number. So then, this case we have to start assuming that k is equal to p square. We have to substitute this value of k as p square here in this equation number 3 and here in equation number 4. So k value will be taken as p square. So it is becomes t double dash p square c square t is equal to 0. Okay now?
Yeah.
T double dash minus p square c square of t is equal to 0. Now go to the first year, second semester differential equation of higher order.
Yeah.
T is a differential equation of second order in terms of t. If I want to find out the solution of such a type of differential equation, we have to find out its complementary function, its particular integral. So this implies, or see how we have to write. Complementary function we can get it, but particular integral we will not get because right hand side value is 0.
Yes.
So this can be written as d square. I am writing first of all operator form, d square t square c square of capital T is equal to 0. If you remember that how we are going to take example, if I want to tell you the example, the differential equation, for example, you have d square y by dx square, okay, plus 5 into dy by dx. This is semester 1, okay, plus 2y is equal to 0. Then you are writing their operator form. How to write operator
Yep.
form? D by dx we have to assume as here our d by dx value, our d value is d by dt actually, because the function is in terms of t. So we have to write operator form. How to write d square plus
D square
5d
plus 5d
plus 2 of
is,
y is equal
yeah.
to 0. This way only we are writing now.
Yeah.
This variable, whatever here it is, y we have to write here. Our variable is t here, right? Just remember first year,
Yeah.
the same
Yeah.
way. Now we have to find out its yc and yp, c of pi. The auxiliary equation we have to find out. For this one, let us assume that it is equation number 3, 4 over now.
Yeah.
So what we can take it is a name. What is the name we can give? Let us assume that yeah, this is taken as equation number 5. Then definitely becomes 6. Okay, equation number 6. So we have to find out the auxiliary equation for 6. The auxiliary equation of equation number 6. You know the process, m square, because d is replaced with m now. M square minus, come on tell me, p square C square is equal to 0.
Square C.
So remember, when writing the auxiliary equation, we don't want to write this y value, right?
Yeah.
What is the auxiliary equation for this one if we want? M square plus 5m plus 2 is equal to 0, correct?
Yeah.
The auxiliary. In similar way, we have to write auxiliary equation here. Now square will go that side, minus will go that side, becomes plus. M square value is equal to what we will get here? C square, C square. So square will go that side, becomes root plus or minus square and root cancel. I'm getting my value of m is plus or minus pc. Plus or minus pc, correct?
Yeah.
Now write down the complementary function for this. How to write? Someone tell me, you have idea? I want to check your knowledge. It is in terms of t. T is equal to two values of m we are getting, and both of them are different. C1 e to the power of p c t. C1 e power x. Remember here, write down the complementary function means we are writing C1 e power x plus C2 e power different. But whatever the value, whatever the solution we are getting,
Yeah.
two solutions we are getting, both of them are different.
Yes.
M1 and M2 are different. So C1 e power whatever may be the solution. So PC is the solution and T is the variable plus
Yeah.
C2 into e to the power of, what do you write? Minus PC. P
Minus PC T.
T values, one solution we got it. We have another case
Yeah.
to solve. Okay. K is equal to P square. We have substituted in the equation number 6. Then we have another part here. You can see another part is this one. Here also we have to substitute here. Here again K value is we have to take as P square. So x double dash minus P square x.
Yes.
So case 2 x double dash minus P square. Someone tell me P square into capital X is equal to, right now?
Yeah.
P value will be taken as P square. This
Okay.
implies that again the same format I want to convert. This format means again I want to convert into the differential equation higher order format. So here we have taken already d now. Let us take another name, that is d dash. We take d dash square minus p square of capital X of capital X is equal to 0. Correct? Same way here we have
Yeah.
done. T is the variable, X is the variable. And where here you have to mention our d value is, here our d value is d by dt, but here our d value is d by dx only. Not d, it's a d dash. Okay, let's
Yeah.
solve it as equation number 7. CF and PI for the 7, but PI is not possible because right hand side is 0. So we write the auxiliary equation. The auxiliary equation of 7 is, for 7 we have to write the auxiliary equation. How it will be? M square minus C square is equal to 0. Same concept, remember here. Look at this one.
Yeah.
This implies that M square is equal to P square. This implies that square will go that side. You will get the value of P. M is equals to plus or minus P only. Now finally, we have to write the solution complementary function capital X is equal to C1, C2 is over. We have taken these two variables. Let us take C3 here. E to the power of two solutions P in terms of X plus C4 e to the power of minus Px. So here we got the value of t, here we got the value of x. Now in this way we write the complete solution. The complete solution of the second case, now complete solution of equation number 1. Complete solution of equation number 1 is equals to, how to write, tell me? Q of x comma t is equal to x and t. And I got the answer is t value is this one, that is C1 e to the power of p c t plus C2 e to the power of minus p c t into into again this one C3 e to the power of px plus C4 e to the power of minus px. Do you have a scientific calculator with you?
Yeah.
Okay. Okay, no problem. So this is called what? This is called exponential function. I am getting the second solution is exponential form.
Yeah.
Exponential form. It is first solution is algebraic form and second solution is an exponential form. Here you can say exponential equation also. So second case is over. We have
Yes.
third case to deal. The third case is what? You have to take that value of k is equal to what? Negative. Okay. Case 3.
Yes.
Case 3. Case 3 and we for our convenience let me call this is equation number 7 हो गया 8. It's very lengthy problem. I told you before only. We have to deal one more case. Which case? When k is, tell me, when k is negative.
Yeah.
0 is over. Positive is over. When k is negative.
Negative.
When k is negative. Assume that that value of k will be is equal to minus p square. Minus p square.
Yeah.
Where p is any number. Where p is any number. Where p is any number. Then this case we have to deal. Where is our equation? These are our equations, number 3 and number 4. If you put in place of k here minus p square, you will get t double dash plus p square c square t is equal to 0, correct?
Yeah.
So let us write down t double dash plus p square c square into capital T is equal to 0. Like a previous concept, I want to convert into the operator form. That operator form is d square plus p square c square of t is equal to 0. Okay, already we have mentioned our d value d by dt here in this case. Called it as equation number 9. You have to write the auxiliary equation for 9. The auxiliary equation of 9 is how to write m square
M square
plus
plus
p square
p square
c square is equal to 0. Then if you bring this value becomes negative, finally our m value is, we'll get the imaginary part I p c, correct? Positive
Yeah.
value will go negative and square will come under the root. So under the root means negative. Negative means we'll write I. Already you are second year student, you can understand this. Now when
Yeah.
you have plus or minus IPC, imaginary parts, how to write the solution? The complementary function t is equal to, remember C1 cos x plus C2 sin x concept, P C T plus C2 sin, you remember this? If you have complex roots means how to write the solution? C1 cos x plus C2 sin alpha plus or minus beta form.
Yeah.
If you are getting two complex roots, then the way of writing the complementary function is C1 cos PCT plus C2 sin PCT. One solution we got it, correct?
Yes.
Another solution, for another solution we have to take again k is equal to minus p square, and again we have to substitute here in this equation. If you put here minus, so minus into minus becomes plus x double dash plus p square capital X is equal to 0, right?
Yeah.
X double dash plus p square into capital X is equal to 0, which implies that again I want to convert this into the higher order differential equation, but in this case I don't want to take d. Give another name, d dash square plus P square into capital X is equal to 0, right? Then this
Yeah.
form again, let us call it as some name. This is equation number 10 we have to take. Now we have to write down the, see, one more important thing, I'm writing only complementary function, particular integral I am not writing. Why? Because right hand side value is 0 now.
Yeah.
If you have right hand side value also something here, e power x or something, then we have to write pi also. For differential equation, there are two solutions. One is called complementary function, another one is called particular integral. Complementary function plus particular integral will become the solution. But now here particular integral not possible because right hand side value is 0. The auxiliary equation of 10, the 10 equation, auxiliary equation for the equation number 10 is what how to write? M square, come on, M square plus P square is equal to 0. Here same situation arises, positive value will become negative here, and then M is equal to, we will get one more time imaginary part, plus or minus IP. Again IP means the capital X will be same solution. C1 C2 is already over. C3 cos px plus C4 sin px, correct?
Yeah.
Now अब लिखेंगे the hence the complete hence the complete solution of equation number 1 is ux comma t is equal to t value here we got c1 cos p c t plus c2 sin p c t into c3 sin p x plus c4 sin px, right? Any doubt till here?
No.
No doubt. अब यहाँ पे देखिए आप, equation number 5 we are going to call algebraic equation. Algebraic equation means if you multiply you will get some polynomial form. Polynomial is a increasing function, right?
Yes.
Polynomial is a increasing function. Exponential function is also a increasing function. If you have a calculator now, see the graph of e power x, it will be always increasing function. And
Okay.
here this equation number we called it as equation number 11. Equation number 11, we are getting some sine terms and cos terms. You know how the graph of the sine and cos in periodic function now, you know, it will be like
Yeah.
that.
Yeah.
For which we are going to find out the solution? We are finding the solution of wave equation. Yes?
Yeah.
How the waves will be? It will be like that only, no?
Yes.
So tell me, among these equations, we have equation number 3, we have equation number 8, and equation number 11. Which of the equation satisfying the physical property of wave equation?
Uh, 11.
That's it. 11 is called the complete solution of wave equation. That's it.
So 11 is the final answer.
You have to write it here. Here we have to write some words here. Hence, periodic functions. Periodic function. Periodic function are present. Periodic functions are present where in equation number 11, and it shows the the physical nature of physical nature of wave, physical nature of wave, physical nature of waves. Therefore, so equation number 11 is the only solution comma which become the complete solution of equation number 1. This is end of this concept. I hope you understand. कब समझ में आएगा आपको? If you are perfect in method of separation of variable, and also you know the graphs of exponential function, and you know the graphs of sin x and cos x, which is there in
Yeah.
intermediate first year periodic functions concept.
Yes.
If you remember all those things, you can understand. Yes, definitely 11 is only the equation which is satisfying the physical properties of wave equation. Then we say that 11 is the solution of wave equation. So this is the procedure. We have to apply for wave equation also separation of variable we are using, and for heat equation also we are using the method of separation of variable. Very, very important concept we have discussed already today. Same concept
Yeah.
will be repeated in heat equation also. Wave
Okay.
equation, heat equation is very, very important concept. No other option in your second unit. If he want to give a question from this, so then he will give either wave or heat. Only two options.
Okay. Oh, I think Fourier series is also there.
The solution we have to find out of, see, the solution of wave equation we can find out using the Fourier series method or Laplace transform method or separation of variable method. But in your syllabus, we have to find the solution by using separation of variable method only.
Okay.
Actually, there are so many methods to solve wave equation. But according to your engineering syllabus, we have to solve by using separation of variable method only.
Okay. So,
Any solution you
if
can, any method you can apply.
okay.
Choice is yours. Why
Yeah.
I am focusing on separation of variables? Because already I shown you the method.
Yeah.
That's what you apply. This method is easy for you. You can apply that. Fourier will become. You have to apply that integral properties. Let's say lengthy process. I feel this is the easiest way, so I am using this.
Okay.
Okay. So let us end up this section. If it is there, if it is any possibility today, because I'm going out, if I come early, then we can have another section, and I will finish it. What we have done today, wave. We'll do it heat also.
Okay.
If I'm getting the time, definitely I'll text you. We'll do it heat also. If not possible today, tomorrow again, inshallah, same time, 11 o'clock. We'll do it heat equation.
Okay.
Right? Okay, thank you.
Yeah.